Here we go with a bit of a review / introduction to a concept that seems simple but is actually very complicated. Electricity. We all have a vague idea of what electricity is, but understanding it completely is a very complex thing. In fact, it's probably safe to say that no one truly understands it completely. We just have some really good models that work really well. What is electricity? Well, it all comes down to the tiny little particle that shares the same name, which is the electron. It basically means the electric particle. And the electron is the guy who is responsible for many of the phenomena that we see that we call collectively electricity. For instance, static, giving your friend a shock by touching them or grabbing a doorknob and getting a shock. Lightning, and even the electricity that we use to power electric devices like light bulbs and heaters and things in our homes, and the computer that you're watching this on right now. So why is the electron so important? I mean, we kind of know that there are some basic ideas about electricity. The most basic is the idea of charge. So first let's talk about that. Charge is the property, it's a property or a characteristic of objects. Property, or you want to call it a characteristic. Characteristic. That basically is what gives something the ability to be electric or do things that are explained through electricity. It's not really a thing you can describe very well because it's not a tangible thing. It's not something you can hold in your hand and touch. It's kind of like trying to describe what happiness is. Well, it's a feeling. It's kind of the way somebody feels when things are going well. Happiness is like a characteristic of people, whereas charge is a characteristic of the fundamental particles that we find that make up matter. So it's a property or characteristic of matter. We know that the charge comes in two types. And these two types of charge, or I guess types is an okay word to use. Another way to think of it is that there is what we call positive, which means you have it, and kind of negative, which means you don't. Positive and negative. And these two qualities, really, the only thing that matters about these two words is that they're opposites of each other. What we have to understand is that with charge, there are two possible ways of having this characteristic, and they are opposites of each other. So any two words could have been used that are opposites, up and down, in and out, black and white. But positive and negative were the words that were chosen for various reasons, and so we're stuck with them. So what does it mean to be positive or to be negative? Well, let's think about some of the fundamental particles that we know of. We know that there are things called protons inside the nucleus of an atom, and there are electrons, and if you pass grade 9 science, you know that there are also neutrons, which now makes me think that I should have indicated there's actually 3 different things you can be if you want to talk about electric charge. Positive and negative, and of course not having any charge at all. But I guess you could argue that that's not really the same thing. Alright, so protons we know are positive charge. Okay, we'll just use a plus for positive from now on. And electrons we know are negative charge. Negative sign. And neutrons are what we call neutral. That's why they're called neutrons. Neutral, which basically means they do not have any charge. So I guess you could say that no charge is another option, but technically that means they're just not electric. If you're electric, you're either positive or negative. And if you're not electric, if you're neutral, then you're just not electric at all. So that means that neutrons don't feel electricity. They don't feel the things that charged particles do feel. They don't respond. They just ignore it completely. So in a way, it's like, not being able to see. We just go through life without knowing or without even being aware that there's things that people can see. Neutrons are sort of blind to electric charge. Okay, so let's look at the atom itself. Remember what an atom looks like. It's got a nucleus and the protons are inside here, pluses. And of course, so are the neutrons, but I'm not even going to put them in because, like we said, they don't even know about electricity. So they don't even matter when we talk about electricity. And then we have the electrons, which we know are sort of on the outside. I'm going to put little e's with a minus. That's usually how we write electrons. And these negative charges are sort of all on the outside of the atom. And that's an important fact, because if you think about it, all things, you, me, cars, all devices, everything is made of atoms, right? Atoms, everywhere. And if atoms have electrons on their outside, that means that the outside of everything is really just like a cloud of electrons. So electrons are on the outside of everything. So that means if two things rub together, let's say you take two objects, this and this, and if they rub together, then it's really they're electrons that are rubbing together. And it's quite possible that when two things rub together, some of the electrons on one, let me draw this circle in red, so these guys' electrons are red, and the other guys are green. Some of these might get rubbed off. They might lose their place. So for instance, here's an atom, plus, plus. Here's another atom. And we'll give this guy 3 little red electrons, and we'll give this guy 2 little green electrons, because atoms always match up, right? The pluses in the center of the atom always match with the minuses so that they even out and they cancel, so they're neutral. So that means the atoms are supposed to be neutral. But if this atom right here happens to get close to this other atom that I've drawn, then it's their electrons that bump into each other. And it's possible that one of the electrons, maybe this red one right here, would get bumped over here and would join up with this guy. And that would leave a messed up picture. It would have these atoms, and you see how this guy would have only 2 left because one of them snuck over here and got stuck with this guy. He was attracted to the positive charges in his nucleus, right? He would be pulled over. And so now we have only 2 redwoods there, and here we have 3. Let's look at what's happened to these atoms. I'll draw a line here so we won't confuse the pictures. Let's look at what's happened to these atoms. Add up the pluses and minuses. Here we have 2 pluses and we have 3 minuses, which means overall there's 1 minus left over. But here we have 3 pluses and 2 minuses, so that means that overall there's 1 plus left over. So you see what's happened? We now have created something that has a positive charge and something that has a negative charge. And we did it by rubbing them together, so that the electrons of one rubbed onto the electrons of the other. If you consider this first guy here, he has more electrons than he should because he got this extra one. He has an excess of electrons. Extra ones. Whoops, SS. Excess of electrons. A negative charge can be thought of as having extra electrons. Whereas this guy, he's missing one. It got rubbed off on the other guy, so he has what's called a deficit or a loss of electrons. And that's what positive charge is often thought to be, or thought of as, a deficit of electrons. So we can see here that rubbing things together can create charges. And so the first way to make charges, we basically call that friction. Charging by friction. Okay? That can give us charge, because electrons can be shifted around. The other way to get charge is what we call charging by contact. If you touch something that's charged, so let's say we took an object. Now instead of an atom, let's draw a big ball, something large. And then we're not going to draw the 5 billion electrons and the 5 billion protons that are found in this ball. We're just going to represent a bunch of them as a bunch of protons plus, plus, plus. Okay? And we'll put also inside the ball, 3 electrons, let's say. Let's make it 4. Let's go 4 red and 4 black pluses. So what we have here is a neutral ball. Okay, neutral. It's not electrical at all yet. It has no charge. But let's say we rub the ball on something. Rub on something. And what happens when you rub the ball on something is that some of its electrons are rubbed away. All right? Some of its electrons are rubbed away. Or they could also be some electrons that get rubbed on. So I'm going to put, there's the 4 pluses, same number of pluses. Let's rub some extra electrons on. 1, 2, 3, 4. And let's say it got some extra ones. 1, 2, 3, 4. Maybe you rubbed it with some rabbit's fur, who knows, and it got extra electrons. Now it has a charge. And that's the kind of charging we just talked about, charging by friction. It has a negative charge, doesn't it? Because there are more minuses than pluses. Now, let's do something else with that guy. Let's take that particular guy and let's put him up close to, in fact, let's touch him against another ball that is just completely normal. So here is the completely normal ball. 2 pluses, 2 minuses, just to show that it's equal and neutral. And now we have our other guy right here, and he has, let me get the count right here, he has 4 little electrons of his own, but he also is carrying 4 little electrons that he got from being rubbed on something. Now that he touches this guy, what we have is a negative charge object touching a neutral object. But because they're touching, the electrons can move. And that's one of the keys to electricity, is understanding that electrons can move. Protons cannot. Let's go back to our picture of the atom up here. Protons are in the nucleus of the atom. Here's some atoms right here. In the nucleus, right here, tied in, and they're held in there by a very powerful force. In fact, you know that positive charges would repel each other. These 4 pluses should be trying to push away. And they are pushing away, but there's a tremendously strong force squeezing them together that overpowers the electrical repulsive force. And it keeps them there. So protons do not move. If they do, guess what happens? Nuclear explosion, nuclear reaction, big time damage. If you rub your feet on the floor and touch your friend and protons move, you'll both blow up and maybe half the city with you. That's not what happens in real life, because protons are very tightly held and don't move. But the electrons are floating around the outside, and it's very easy for them to get bumped around and for one to fall and get knocked into the orbit around another atom. So you see, this is what's going to happen here. The electrons, the minuses, are kind of free and easygoing. They can move. And they will be attracted to the positive protons in this neutral object. So what will end up happening is the charge that's all there will sort of be shared amongst both of them. So what will happen is this neutral object sitting here will attract the protons inside. The positive protons will attract some of the other electrons. Now the total number of electrons is 10. And so maybe some of these guys will get pulled over here, and some of them will stay over here. If you count up, there's still 4 red electrons that were present here in this object. And there's still 4 green electrons that were rubbed onto this by something else. And there's still 2 purple electrons that were in here. All of the electrons are all accounted for in this new joined up touching objects. But notice how they spread out. So the charge spreads out over the 2 objects. So when you touch something that has a charge, you get a sharing of the charge, or spreading out of the charge over the whole object. Now count up. Now if you take them apart, so the last little picture, we'll just take them apart now. And when you take them apart, guess what? Well, those electrons kind of stay where they are. So now you have this guy with 2 purples, and he has 2 little red ones. This guy has 2 little red ones. And there's 3 little green ones over here, and there's only 1 little green one there. Count them up. 2 pluses, 5 minuses. a charge of -3. And what's this guy got? 4 pluses and 1, 2, 3, 4, 5 minuses. A charge of -1. Originally, we had neutral right here, and if you counted it, there were 4 pluses and 1, 2, 3, 4, 5, 6, 7, 8. 8 minuses, which would be a charge of -4. The -4 charge that we had was broken up into a -1 and a -3. So it was spread out. The electrons were spread out among the two objects. That's another way to get charge, by touching something that's charged. There are other ways to get charged. In fact, there are lots of ways. And in grade 9, you probably also learned about charging by induction. And then there are other ways that we could talk about. But this is just a review to give us the idea. So we won't worry too much about charging by induction today. Maybe we'll do another video on that because it's complicated and it's a little bit more of a big deal. This video, we just wanted to make a short video to remind us about how matter is made of atoms. Electrons are on the outside of atoms, and when matter rubs together, electrons can be rubbed off of one thing onto another and can create charges. And you can also get a charge if you touch something that's already charged by contact. And that's basically the way that electrons are involved in electricity. Also remember what we call the laws of electric charge, which are basically what describes, whoops, let's write that properly, not electrons, electric charge. The laws of electric charge, which basically say that one, opposite charges attract each other, opposite charges attract, and you may recall that if you have two similar charges, I can't spell today, not attack, sounds like a war, attract each other. And number 2, similar charges or like charges, 2 pluses or 2 minuses, repel each other. And that's basically the sort of summary and introduction for the basis of electricity. In the next video, we'll talk a little bit about static electricity and how that works. And then we'll have another video later talking about current electricity, and that'll bring us sort of up to speed with all of our grade 9 stuff. And then we can start looking at some of the more complicated stuff that we get from it that we'll study in grade 12.